Hello, welcome back. Welcome back. I'm John, an old YouTuber and gamer. Let's continue my reading. That's Masatoshi Shima. He's one of the founder of the Zilog. That's Frederico Faggings. The Frederico Faggings, that was sorry for my voice. I need something to drink. Sorry. This is Sunday. It's Sunday morning. So I don't know what's wrong with my voice. It's not morning, it's 10:45. Yes, but let's just continue. Know him, Masatoshi Shima. I cannot pronounce it. He's one of the founder of the Zilog. And Frederico Faggins, that designed the first Intel 4004 and the 8080. He's one of the co-founders of the Zilog. So I need to finish that. Let's close. Yes, but this is the 15 minutes thing. But this will take the whole summer if I should do this. Yes, we are the Sunday the 15th, and that will take my whole summer to read that. But that's fine. I'm low on money and I have nothing to do. I'm not going to travel or anything because I don't have money for that. I actually like to read this myself. Yes, I never read all this, and that's very helpful. This computer voice is very helpful. This English computer voice, that's helped me a lot to understand, yes. But I got a little bit more sleep tonight. I just like to get started. We have recorded soon, 4 minutes. I need a little bit time to adjust the screen and the camcorder. And get back to my bed. But it's not a long one. That's only 4 pages. We can do this. We can do this below. Yes, but I need to lay in my bed and do this because my back is hurting. So let's just start. Read to the end of the documents.
Masatoshi Shima. Professor Masatoshi Shima. Dr. M. Masatoshi Shima.jpg. Masatoshi Shima at the Computer History Museum 2009 Fellow Awards event, born August 22, 1943, Shitsuoka Prefecture, Japan. Citizenship, Japan. Education.s. Tohoku University, 1967. Dr. N. Tsukuba University, 1991. Known for microprocessors Intel 4004, 8080 Zilog Z80, Z8000 peripheral chips, Intel 8259, 8255, 8253, 8257, 8251 Awards Kyoto Prize, 1997, Computer History. Masatoshi Shima, Shima Masatoshi, born August 22, 1943, Shitsuoka, is a Japanese electronics engineer. He was one of architects of the world's first microprocessor, the Intel 4004. In 1968, Shima worked for Bizicom in Japan, and did the logic design for a specialized CPU to be translated into 3-chip custom chips. In 1969, he worked with Intel's Ted Horf and Stanley Maser to reduce the 3-chip Bizicom proposal into a 1-chip architecture. In 1970, that architecture was transformed into a silicon chip, the Intel 4004, by Federico Fagin, with Shima's assistance in logic design. 3, 4, 5. He later joined Intel in 1972. There, he worked with Fagin to develop the Intel 8080, released in 1974. Shima then developed several Intel peripheral chips, some used in the IBM PC, such as 8259 interrupt controller, 8255 programmable peripheral interface chip, 8253 timer chip, 8257 direct memory access, DMA, chip, and 8251 serial communication UART chip. He then joined Zilog, where he worked with Fagin to develop the Zilog Z80, 1976, and Z8000, 1979. 2. Contents. Early life and career. Intel 4004. Intel 8080 to Zilog Z8000. Prizes. Notes. External links. Early life and career. He studied organic chemistry at Tohoku University in Sendai-Miji Prefecture, Japan. With poor prospects for employment in the field of chemistry, he went to work for Bizicom, a business calculator manufacturer, joining in spring 1967. There, he learned about software and digital logic design, from 1967 to 1968. 3. Intel 4004.
Okay, I have to read page by page. It's not always it can read the whole documents.
Museum Fellow, 2009. 1. Scientific Career Fields Electronics Engineering Microprocessor Institutions Bizicom, 1967 to 1972, Intel, 1972 to 1975, Zilog, 1975 to 1980, 2. University of Asia, 2000. After Bizicom decided to use large-scale integration, LSI, circuits in their calculator products, they began work on what later became known as the Bizicom project. 5. A chipset for the Bizicom 141PF calculator that led to creating the first microprocessor, the Intel 4004. 4. In April 1968, Shima was asked to design the logic for what was intended to become a future chipset to be designed and produced by a semiconductor company. 3. Shima designed our special-purpose LSI chipset, along with his supervisor Tadashi Tanba, in 1968. 4. His design consisted of 7 LSI chips including a 3-chip CPU. 5. Shima's initial design included arithmetic units, adders, multiplier units, registers, read-only memory, and a macro instruction set to control a decimal computer system. 4. Bizicom wanted to produce a general-purpose LSI chipset, for not only desktop calculators, but also other equipment such as a teller machine, cash register and billing machine. Shima began work on a general-purpose LSI chipset in late 1968, and Bizicom then approached the American companies Mostek and Intel for converting the logic into MOS circuits and the chip's layout for manufacturing. The job was given to Intel, who back then was more of a memory company and had facilities to manufacture the high-density silicon gate metal oxide semiconductor, MOS, chip Bizicom required. 3. Shima went to Intel in June 1969 to present the proposal. Due to Intel lacking logic engineers to understand logic schematics or circuit engineers to convert them, Intel asked Shima to simplify the logic. 3. Intel wanted a one-chip CPU design. 3. Influenced by Sharp's Tadashi Sasaki, who had presented the concept to Intel in 1968. 6. This was then formulated by Intel's Marcy and Ted Horf in 1969, simplifying Shima's initial design down to 4 chips, including a one-chip CPU. 5. Due to Horf's formulation lacking key details, Shima came up with his own ideas to find solutions for its implementation. They both eventually realized the 4-bit microprocessor concept, with the help of Intel's Stanley Maser to interpret the ideas of Shima and Horf. Shima was responsible for adding a 10-bit static shift register to make it useful as a printer's buffer and keyboard interface, many improvements in the instruction set, making the random access memory, RAM, organization suitable for a calculator, the memory address information transfer, the key program in an area of performance and program capacity, the functional specification, decimal computer idea, software, desktop calculator logic, real-time input /output, I/O, control, and data exchange instruction between the accumulator and general-purpose register. 3. The specifications of the 4 chips were developed over a period of a few months in 1969, between an Intel team led by Horf and a Bizicom team led by Shima. 5. After Shima went back to Japan in late 1969 and then returned to Intel in early 1970, he found that no further work had been done on the 4004 since he left, and that Horf was no longer working on the project. The project leader had become Federico Fagin, who had only joined Intel a week before Shima arrived. Fagin was hired from Fairchild Semiconductor, where he had developed the original MOS silicon gator technology, the only technology that could be used to design a chip of the complexity and speed of the 4004. Shima worked with him, assisting him with the logic design the 4004 processor. 3. He worked at the Intel offices for 6 months, from April until October 1970. His company then sold the rights to use the 4004 to Intel, with an exception for use in business calculators. Intel 8080 to Zilog Z8000. After the 4004, Intel designed the 8008 architecture by Computer Terminal Corporation, designed by Federico Fagin and Hal Feeney. Shima then joined Intel in 1972. 2. He was employed to implement the transistor-level logic of Intel's next microprocessor, which became the Intel 8080, conception and architecture by Federico Fagin, released in 1974. 3. Shima then developed several Intel peripheral chips. Some used in the IBM PC, such as the 8259 interrupt controller, 8255 parallel port chip, 8253 timer chip, 8257 DMA chip and 8251 serial communication UART chip. 2. He was not involved in the creation of Intel 8088 or 8086. Shima moved to Zilog in 1975 and, using only a few assistants, 7. developed the transistor level and physical implementation of the Zilog Z80, under the supervision of Fagin, who conceived and designed the Z80 architecture to be instruction set compatible with the Intel 8080. This was followed by the Masatoshi for the 16-bit Z8000.3. According to co-workers from Intel, Fagin's method that Shima used was to design all logic at the transistor level, directly and manually, not at the gate and forward/or register level. The schematics were thus hard to read, but as transistors were drawn in such a way that they suggested a floor plan of the chip, it helped when making the physical chip layout. However, according to Shima, the logic was first tested on breadboards using transistor logic, TTL, chips, before being manually translated into MOS transistor equivalents. After returning to Japan, Shima founded the Intel Japan Design Center in 1980, and VM Technology Corporation in 1986. At VM, he developed the 16-bit microprocessor VM860 and 32-bit microprocessor VM8600 for the Japanese word processor market. He became a professor at the University of Asia in 2000. Prizes: 1997 Kyoto Prize, Advanced Technology. 2009 Fellow of the Computer History Museum for his work as part of the team that developed the Intel 4004, the world's first commercial microprocessor. 9. Notes. 1 Masatoshi Shima 2000.
Yes, we will not read this, so we have 3 minutes left. So that was Masatoshi Shima. I cannot pronounce that, but I will just continue with my reading lists. Then I will do like that. Then I will continue with the Zilog. Yes, but we can do this. I'll just start to upload this. I will start to upload, then I'll just follow my read list. But maybe I'll change it later. Yes, let's close it. And the next is this, try to finish the Zilog. So do there's 5 Zilog there. And yes, but I'll just continue this